the second day for section 4.5. We're going to continue writing functions and writing function rules. Today we're going to just focus on the odd numbered problems. You'll do the even ones on your own. So number one, it says Eric is 2 years younger than 3 times his sister's age. Write a rule that represents Eric's age, A, as a function of his sister's age, S. How old is Eric if his sister is 11? So the first thing we want to do is write the rule. There are two variables. We have Eric's age, which is A, and we have his sister's age, which is S. Okay, and then it says Eric is 2 years younger than 3 times his sister's age. So 2 years, so 2, and then younger would mean we'd be dealing with some sort of subtraction, and then 3 times his sister's age, so 3s. Okay, now we're ready to write the rule. For these problems it tells us, so yesterday we had to determine what the dependent and independent variable was, and whatever the dependent was, we capitalized that. Here it says to write a rule that represents Eric's age A as a function of his sister's age S. So A as a function of S. So that means we capitalize the A, and the S is going to be lowercase. So A, and then parentheses, the S is lowercase. Alright, and then so Eric is 2 years younger than 3 times his sister's age. Remember that when you're dealing with subtraction here, pay attention to the order. So we want 2 years younger than 3 times his sister's age. So this is going to be flipped. This is going to be 3s minus 2. So there is your function rule. Now, how old is Eric if his sister is 11? So we were going to plug in 11 for S because that's his sister's age. So we want A of 11. And what does that equal? 3 times 11 minus 2. Now, we don't have to do anything with that. We're just evaluating what's on the right here. So 3 times 11 is 33 minus 2. 33 minus 2 is 31. So Eric is 31. Okay, for the third one here, this one's a pretty challenging problem, so you're going to have to pay attention. So it says write a function rule for the area of a rectangle whose length is 6 feet more than its width. What is the area of the rectangle when its width is 12 feet? Alright, so we want a function rule for the area. So area will be one of our, so A is going to equal total area. And then we have to decide, alright, our second variable, is that going to be length or width? And the answer is going to be width. And how do I know that? Well, we ultimately want to be able to plug in 12 feet for the width. Alright, so W is going to be width. Alright, so we want to involve W. All right, we're not interested. We're not going to be plugging in anything for length, so that's why we didn't include it. We put our width instead. All right, so write a function rule for the area in terms of width. So the A gets capitalized, and then our width will be lowercase and inside the parentheses. Now we know that area is equal to length times width, but we want to put the length in terms of W. Alright, so we know that the length is 6 feet more than its width. Alright, so I need some more room. So area equals length times width. And we know that the length is 6 feet more than its width. So it's W plus 6. And then the width is just W. So I'm going to take this and write it up as a part of my rule. So W plus 6, that's my length there, times W. Okay, so I wrote my function rule. I'm going to box that in because that's an answer. And then when the width is 12, what's the area? So now I'm plugging in 12 for W. Okay, and then put that in your calculator. So we have 18 times 12, so it's going to be 216 feet squared. So that's your area. Okay, number 5. A young sumo wrestler decided to go on a special high-protein diet to gain weight rapidly. He started at 90 kilograms and gained weight at a constant rate. After 8 months, he weighed 138 kilograms. So let W of T denote the sumo wrestler's weight W, measured in kilograms, as a function of time T, measured in months. Write the function's formula. Alright, so there's a lot here. First, write the function's formula. Alright, so it tells us how to start it. W of T equals. Alright, so we know that W is the weight and that's in kilograms, and we know T equals time in months. Alright, so what did he initially weigh? He initially weighed 90 kilograms, so we're going to put that first. And then he gained weight at a constant rate, so gain would indicate we're adding. So how much weight did he add per month? Well, we know that after 8 months, he weighed 138 kilograms. So, how much did he gain in 8 months? Well, he started at 90, so 138 minus 90, what's that? That gives us 48. He's gained 48 kilograms in 8 months. So what's that per month? So 48 divided by 6, 48 divided by 8, that's 6 kilograms. So we know that the weight added is constant, so it's the same every month. So he adds 6 kilograms of weight per month. So here's our function rule. And that's all that particular problem asks of you. Alright, and let me erase this M. It should be a T. And T represents the number of months. Now we're okay. Okay, finally, the last one, number 7. Diane has already taken 1 quiz during past quarters, and she expects to have 1 quiz during each week of this quarter. Write an equation that shows the relationship between the number of weeks W and the total number of quizzes Q. Now it says write your answer as an equation with Q first, followed by an equal sign. Alright, so our variables it tells us. Let's write those down first. So W equals number of weeks, and Q equals total quizzes. It wants us to put Q, wants us to write Q first, and then followed by an equal sign. So that, in other words, the total number of quizzes equals, and now we want to write our expression here. So Diane has already taken 1 quiz during the past quarters. Alright, so that's our initial value, if you will. Alright, so she starts off with 1, and she expects to have 1 quiz during each week. So 1, you can also think of this as 1 quiz per week. Alright, so you have the 1, the per means multiply. Our variable W represents week. So 1 times W is just W. So she's already had 1, and then she's going to add 1 per week, or 1W. But instead of writing 1W, let's just write W. Get rid of the 1. Alright, and there's your equation.